Okay, let's take a look at this guy. It is second order DE, non-homogeneous. We do not have zero on the side. It is linear though. I could put that in the title here. Linear. Because it's a linear function of y. Cosine's not linear. We don't care what's happening to x. All the y's are to the first power. No signs of y's, no y squared, nothing like that. Okay, so we're going to do this in two parts. We find our yc, our complementary function, and our particular solution. In fact, we're going to find two linearly independent particular solutions and then add them together. We can do this one piece at a time. How do we find yc? We solve, so let's say here, for yc, we solve the homogeneous version, y double prime minus 4y prime minus 12y equals 0. So we ignore all the stuff over here. We just set it equal to 0. And I'm just going to jump straight to the characteristic polynomial. Lambda squared minus 4 lambda minus 12 equals 0. Remember, the powers match the order of each derivative. You should be able to factor that in your sleep. And you get two solutions, 6 and -2. That means my characteristic solution, yc, will be c1 e to the 6. No, now, am I using x or t? I have to look over here to see. I'm using x plus c2. And again, order doesn't matter here. I could put these in the other order. E to the -2x. This is not a solution to the DE. If I were to plug that into the original DE here, you could try it on the left side. You'll get 0. This side ain't 0. So we're not done. You can't stop there. Now we need to find our particular solutions. And I could do this all at once. Like sometimes I do, even if I have something like this, I'll just assume some function that will match all of this. But usually I find it easier to do these one at a time. So let's call this guy here G1 and this guy G2. Okay, so for G1, and that's a function of x, let's try a particular solution. If you just tried this, it's not going to work out. You could try it. Go back to the original DE. It's not going to work out. If this is a linear function, I need my particular solution that I'm trying to be a full linear function. If I had a quadratic over here, I would need ax squared plus bx plus c. Then his first derivative is a, excuse me. His second derivative will be 0. No, I'm not going to edit out that sneeze. I apologize for it, but it would take me an hour to edit it out. I'm sorry. All right, now we plug all that back into, we want the left-hand side just equal to that G1. So what was that? Y double prime minus 4y prime minus 12y just equals 12x or 2x. So let's plug all of those in and see what we get. Get this out of my way. 0, I'm going to write this out in all its glory, minus 4 times a minus 12 times all of that. And that's just supposed to equal 2x. Now, the only way these two polynomials of x can be equal is if all the coefficients are equal. So I need to clean this up. 12ax minus 12b is supposed to equal 2x. I got to collect my like terms in terms of powers of x. So I've got a minus 12a x plus negative 4a minus 12b. And that's supposed to equal 2x plus 0. So I've got all my x's together, all my constants together. Now, negative 12a must equal 2, and this constant must equal this constant. If I had a quadratic, I would compare coefficients that were the x squared coefficients, then the linear coefficients, then the constants. All right, so I mean, we've got a system of equations here, but it's pretty easy to solve. I've got negative 12a equals 2, so a is negative 2 over 12, negative 1/6. Then I've got negative 4a minus 12b equals 0. So let's plug that in there. So that cleans up. That's what? 2/3 equals 12b. So bringing the 12 down, 2 over 36. So b is 1 over 18, I think is what we get. So my first particular solution, what was a? Negative 1/6. All right. Now, what I'm going to do is pause and go check and make sure that's correct before I get too far in this video. And that is correct. Okay, now we deal with the second guy. So now we deal with G2 of x, which was, I've forgotten, 5 cosine x. And again, I could have done this all at once. That would have been perfectly fine. I just find it easier to do these one piece at a time. So I set the left-hand side equal to that, and I assume something whose first and second derivatives are going to just spit out a cosine. And you might think, oh, I'll just try this. Some a cosine of x. Okay, a couple of things I want to point out here. First, I know I've already used the letter a. I remember when I was taking this class, this would have bothered me. No, I've already used the letter A. I can't reuse the letter A to mean something different. Sure, I can. All this work is done. I used A, I solved for A. I'm done with that. Forget it. A goes back in the pool now. It's free to be used again. Secondly, you make this assumption, you go ahead, try it. Right here, his derivative is going to spit out a sine. His second derivative is going to get you back to a cosine. There's not going to be any way to get rid of that sine. This isn't going to work. If you have a sine or a cosine, then you have to assume your particular solution has both for a second order, even if you got a y prime in here. Like if this term didn't exist, that would have worked. It's because of this guy, when I take his derivative, I would pick up a sine that there's no way I'm going to cancel out. So I need both sines and cosines. Okay, and now this is a little bit of work. This is going to get a little tedious here. Derivative of sine is negative, or derivative of cosine is negative sine. Derivative of sine is cosine. And now second derivative. The derivative of sine is positive cosine. Derivative of sine, cosine is negative sine. And I have to plug all three of these back into my DE here. Y double prime, Y prime. Don't forget your 4 and your 12 there. And then the original. Okay, let's plug all that in. So this guy here, I'm going to put everything in parentheses here so we can see where everything came from. And then it's minus 4 times the derivative right there. You just got to be really careful. Where you're going to mess these up is messing up a sign. minus 12 times this guy, the original. And that's all supposed to equal the other side, 5 cosine of x. Okay, let's clean that up a little bit. So I'm just going to go through and do my distributing, and then I'll collect the like terms. So I'm going to get a plus right there. Minus here, minus 4b cos, minus 12a cos, and minus 12b. Sine. And that's all just supposed to equal 5 cosine of x. All right, now let's collect all of my cosines together. So I've got 1, 2, 3 cosines on the left. So I'm going to write it like this: cosine of x, and I've got a negative a minus a 4b minus another 12a. And that's supposed to equal the cosine on the other side, 5 cosine. Now let's collect all of our sines together. So times sine, I've got a negative b, a 4a, and a minus 12b. How many sines do I have on the other side? 0 sine. Okay, so I'm going to circle this because that's an important step there. All right, now we can clean that up. So what do we get? Negative 13a minus 4b is supposed to equal 5. That coefficient must equal that coefficient. And negative 13b plus 4a should equal 0. I've got this system of equations I need to solve. Now, personally, I would just solve this by substitution, and that's what you're going to watch me do. But it's perfectly fine if we solve this using a matrix, if we solve this using an online system of equations solver. Like, it would be okay if I just went here, Wolfram Alpha. That's not going to work. Negative 13 minus 4, 5. Minus 4b equals 5, comma. And then I think we had, I'll check this to be sure, minus 4a equals 0. Let me make sure that was right. Oh, was it plus 4a? I think it was. And we get our two solutions. Negative 13 over 37, 4 over 37. We get our two coefficients, I should say here. That's perfectly fine. We could also do this in our calculator. I could set this up in matrix form. I could say the vector, or the matrix, negative, let's write it this way, minus 4 minus 13, 4 times the vector AB should equal the vector 5, 0. You should have learned how to do this in pre-calc. That doesn't always happen. Now I can set this up in what we call our augmented matrix. Let me write that there. So I'm going to rewrite this matrix. I'm going to put in this dotted line here. And I'm going to put this constant vector over here on the side. All right, now let me open up my calculator. Okay, so I'm going to go into the matrix feature, which is right there. So I have to hit second to get to it. I'm going to go to edit, and I'm going to pick a brand new and I didn't. Sorry. I'm going to pick a brand new matrix, edit, and go down to E here. Remember with matrices, we always do row by column. So I have 2 rows and 3 columns. And now I just type in. Now you got to keep in mind, this is your negative button. That's your minus button. I need to do negative 13. And I'm just going to hit enter as I go, and it will scroll me over. -4, 5, -13, +4, 0. Now, I have a habit of messing up my matrix when I'm in here. Get out of this menu. Quit. Get out of there. And just to make sure you typed it in right, you can come back here to matrix menu, go to E and just hit enter on him a couple of times. Let it spit it out, and you can double check that you put everything in correctly. Okay, that's just checking. Now let's actually solve this matrix equation. We're going to go back into the matrix menu. We're going to go over to math, and we're going to go down to row reduced echelon form, RREF. We hit enter, and right now it's asking me, which matrix do you want to use? And I've seen people do this. They see that there is an E right there. See that green E? They'll do this. That is not the matrix E. To get matrix E, you have to go back into the matrix formula, matrix button, grab it from there, close your parentheses, and we're done. There are my 2 solutions. That's A, because we had A on top. That's B. Now, I don't know if you know this about your calculator. No matter what answer it spits out, if that is a rational number, you can have your calculator convert that back into fraction form. So now I can just hit the math button and just number 1, I just hit enter twice. Into fraction, it'll spit that out as a fraction. Is that the same answer we got a second ago? Let me pause a second here. Hold on. That is not the same answer because I done goofed. And I'm going to leave this in the video because this is a very common mistake to make. When I'm going to write this in matrix form, I need to have my guys lined up properly. My A's need to be lined up. My B's need to be lined up. I did this on purpose because this is a common mistake. That's a different answer than we just got using a system of equation solver because these have to be in the other order. These 2 guys here need to be switched. So what we should have right here, 4A minus 13B. Everybody's got to be lined up. So this should be 4 here, -13 there. So your A's and your B's need to be lined up. So quick fix here, we just come back into the matrix. That was, and we got to go to edit to get there. That was matrix E. And I can just scroll through, hit enter. This was 4 and -13. Enter. Quit. Get out of here. Then come back in, second matrix, over to math, down to RREF, row reduced echelon form. And I want to apply that to matrix E. Close my parentheses, hit enter. And then again, I can have my calculator convert this into fractions. So we get A, -13 over 37. And B was -4 over 37. And as I mentioned at the beginning, I probably wouldn't go through all that work. I would probably just take this guy and just do a back substitution. I would solve this equation for A, substitute over here. It does look like it's some nasty fractions. Maybe I would do it this way. I don't know. But back substitution is always fine too. Like you guys know like 10 different ways to solve system of equations now. Okay, now that we've got that, that means my second particular solution, remember it was A cos plus B sine, will be -13 over 37 cos x plus -4 over 37 sine x. Now we can put together everything. My full general solution is going to be my complementary solution plus both of these particular solutions. These are y's, not g's. All right, and it's a good thing we circled those all the way down. So we had 6 and -2. We had that first solution we got from that linear non-homogeneous part, -1, 6 plus 18, 1 over 18. And then we've got this guy. So we'll just tack him at the end. -13 over 37 cos -4 over 37 sine. Now, this is really important. If we were solving an initial value problem, we would have to wait until this very moment before we start plugging in our initial conditions. A lot of mistakes happen. This video is already too long, so I'm not going to do that here. A lot of mistakes happen. If we have an IVP, we're given two initial conditions, a lot of times students will, right up here, try to solve for C1 and C2 way too early. If you have an initial value problem, you have to wait until the very end when you got everything in there before you plug in your conditions. Otherwise, you'll get completely the wrong solution. And that is a good place to stop.